Okay, you've seen this before. I like to talk about it early in the semester and bring it up quite a bit. If I said, write the product that results when aluminum reacts with oxygen, you'd say, oh my, you gotta be a chemist to do that. Well, that's because the chemist looks at a periodic table and figures out the charges. Aluminum, 3 over there, Roman numeral 3 up above there, has 3 valence electrons. When those go away, it forms a +3 cation. And then oxygen, 2 columns away from neon, it'll take on 2 extra electrons. Or we look at Roman numeral 6 and subtract 8 and get to -2. Once we know the charges, we know they have to combine in such a way to be electrically neutral. So I typically ask, what's the least common multiple between 3 and 2? The answer is 6. 3 goes into 6 twice. 2 goes into 6 3 times, or we swap the charges for subscripts, and the subscript gives us the number of that atom in the formula unit. Why do I call this a formula unit and not a molecule? Molecule is reserved for molecular compounds. What kind of compound is this? It's ionic, absolutely. How do you know it's ionic? Metal and a non-metal. So my favorite topic, nomenclature. Chemists have developed systematic ways to name compounds. If you learn the naming rules, you can examine a compound's formula and determine its name, or from a name, draw a formula. Many compounds have common names. H2O has the common name of water and the systematic name of dihydrogen monoxide. Sounds poisonous, you say it like that. Since water is such a familiar compound, everyone uses the common name, not its systematic name. No, geeks in chemistry class will and do at the cafeteria. Common names can be learned only through familiarity, and there's no system. Everything else is going to have a system. How do we name compounds? First step in naming an ionic compound is to identify it as one. And how do you do that? 30 seconds ago, somebody else told me, yeah, metal and a non-metal. That's how you identify an ionic. How do you identify a metal? It's over on that part of the periodic table. Non-metal's over on this side. I'm going to try not to read lots of my slides. I'm going to try and do a song and dance or something else. All right, ionic compounds, we have 2 types. Those metals that have fixed charges, mainly everything in those first 2 columns, aluminum, and that's about it. And then there's a few D-block metals. So type 1 contains a metal with invariant charge. Fancy word for say it has a fixed charge. That means it doesn't vary from one compound to another. Magnesium is always +2 in every compound it ever forms. All right, type 2 might be something like iron. We have iron 3, iron 2, manganese 2, manganese 3, manganese 4. These are in that D block, or what we might say the transition metals section of the periodic table. Metals that form more than one type of ion, and metals that form just one type of ion. So here are the metals that just form one type of charge. Magnesium, always +2. Everything in that second column is always +2. Everything in the first column is always +1. Now here's aluminum. It's in the P block and there's a Roman numeral 3 there. So here's the only D block metals that for the most part have fixed charge, so they make the list. And it says here the charge of these metals cannot be inferred from where they appear in the periodic table. So chromium 2, chromium 3, there's chromium 6. There's too many of a lot of these to put all in one table. Iron 2, iron 3, cobalt 2, cobalt 3, copper 1, copper 2, tin 2, tin 4, mercury 2, the mercurous ion. It's very curious. There's 2 stuck together, so the overall charge is 2. We won't worry about that a whole lot right now. Mercury 2, lead 2, lead 4. So there's 2 ways to name these ions. The stock system is what the IUPAC system of naming uses, where we just say the name of the metal followed by a Roman numeral that gives us the charge. These are all cool and neat. The us is always less than the ic, but it requires you memorize that ferric is iron +3, then ferrous, you know, is 1 less. But then here, well, that will kind of, here with copper, this is cupric, this is cuprous. So it requires you have to do a little more memorization with those metals. So naming binary compounds with type 1 metals, very straightforward. You've heard me say sodium chloride. So chlorine, change it a little bit so it ends in "ide." Potassium oxide. So it can't get any easier than this. You just say the name of the metal. This might require you sodium sulfide. Since the charge of the metal is always the same for these types of compounds, the charge need not be specified. I don't say potassium 1 oxide. And I definitely do not go dipotassium oxide. The di and tri we reserve for molecular compounds. Sodium chloride followed by the base name of the anion. So chlorine, chop off the I or the Ne and put IDE to get the chloride. So no sodium chlorines out there, it's sodium chloride. And here's the base name, and they all end in "ide." And how do we figure out these charges? Where's nitrogen in the periodic table? Has a Roman numeral 5 above it. 5 minus 8 equals a -3. Or I look over there and I go oxygen, fluorine, neon. I got to jump over 3 times. Nitrogen can take on 3 more electrons to have the same number of electrons as neon. All right, I better stop and let you take your quiz.